Okay, so good day to all of you. As promised, I will provide this tutorial so that you will have an idea. So this example is discussed in chapter 8, deadlocks, slideshow presentation. So as to know how did the sequence is produced, so I'm going to demonstrate here in this tutorial. So again, let's have a recap of the given problem or processes in the slides, or the example of banker's algorithm. So we have 5 processes, P sub 0 through P sub 4, and then we have 3 resource types. So we have A is 10 instances, B is 5, and then C is equal to 7. And then we have snapshot at time T sub 0. So we have the 5 processes from P sub 0 to P sub 4, and then the allocation matrix for each of the processes, and then the maximum needed resources by these processes, and then we have the available values for A, B, and C. So before we start our how are we going to determine if this set of processes is safe while executing of course themselves, as these are processes. So first, let's derive the matrix need. Okay, so need is equivalent to or equal to max minus allocation. Okay. So, max minus allocation. And then, of course, you have to consider these matrices, A, B, and C, as independent numbers. There are not, as I've said, as a review, it's not 753 or 322, 902, 222, or 433. They are regarded as independent numbers. So, for example, for P sub 0, so the maximum needed resources of P sub 0 for A is 7, then for B is 5, and then for C is 3. And then for this allocation, it means that P sub 0 has already acquired 1 instance of B. So that's why we need the need matrix, so that we can identify how many more resources does, for example, P sub 0 need to complete its execution. So let's derive the need matrix. Okay, to derive the need matrix is, of course, we have need, and then resource A, resource B, and resource C. And then we have for P sub 0, P sub 1, P sub 2, P sub 3, and P sub 4. Okay, again, need is equal to max minus allocation. So, let's subtract from A to A, B to B, and then C to C. So, for P sub 0, 7 minus 0, of course, is 7. And then 5 minus 1 is 4. And then 3 minus 0 is 3. So, for P sub 0, the needed resources for A, B, and C is 7, 4, 3. And then for P sub 1, 3 minus 2 is equal to 1. 2 minus 0 is 2. And then 2 minus 0 is also 2. So, for P sub 1 is we have 1, 2, 2. And then for P sub 2, 9 minus 3 is equal to 6. 0 minus 0 is equal to 0. And then 2 minus 2 is equal to 0. And the next is we have P sub 3. Okay, so we have 2 minus 2 is equal to 0. And then 2 minus 1 is equal to 1. And then 2 minus 1 is also equal to 1. So for P sub 3 is we have 0, 1, 1. And then for P sub 4, 4 minus 0 is 4. 3 minus 0 is 3. And then 3 minus 2 is equal to 1. So P sub 4 is we have 4, 3, 1. Okay, so we already derived the need matrix. Okay, next is we have, take note of the available. So, our available is what? 3, 3, 2. So, let's put available here. So, B, and C are available is 3, 3, 2. Okay, let's compare our available 3, 3, 2 to the corresponding need values of the processes from P sub 0 to P sub 4. Okay, can P sub 4 be entertained first? Actually, no, because for resource A, it needs 7, the available is only 3, and then for resource B, it needs 4, the available is only 3, greater than. The only, and also, C also is, it cannot be accommodated because the available for resource C is only 2, and then for P sub 0 is we have 3. Okay, so P sub 1, can it be granted the request for the need? Actually, yes, because it fits. It only needs 1. The available is 3. For B is 3, and then the available is, the need is 2. And then for C, the available is 2, and the need is 2. So P sub 1 is a candidate. Next is we have P sub 2. Can it be granted? No, because for resource 8 needs 6, and only the available resource for A is 3. And then actually there's no problem with B and C because P sub 2 does not request such resources. But again, because of resource A, it will never be accommodated even though B and C can be accommodated. The rule here is that all of the resources must be acquired so that it will do its execution. So for P sub 3, that is it can be granted and the available is 332? Actually, yes. So because it doesn't need any resources from A, and then B is 1, so it is less than the available, and 1 also for C, and it's also less than. Actually, this is also the candidate. And then for P sub 4 is we have 4, 3, 1. Okay. Will it be granted? For C, yes. For B, yes. But for resource A, no. Because for P sub 4, A, it needs 4 instances, while the available instances of resource A is only 3. Okay, since our candidate is P sub 1 and P sub 3, you can choose either which of them is you're going to be the first to be granted the request for the need. Actually, the solution here, if the question is determine if these processes will be in a safe state, as long as you will identify a sequence that all of the processes will finish its execution, then the system will be safe. It does not really matter. The question here is there only one absolute answer? So let's see. So since we have P sub 1 and P sub 3, let's test for P sub 1 since this is the index is lower. So that's just a reason. Because actually both of them can it either be P sub 1 or P sub 3. But let's try P sub 1. Okay, so since this is the first process that you're going to execute, so let's write it in here, P sub 1. And then since this is still the needed resources by P sub 1, you have to subtract the need values of P sub 1 to available. So, for the P sub 1 to start its execution. So, we have 1, 2, 2. So, 2 minus 2 is 0. 3 minus 2 is 1. And then 3 minus 1 is 2. So, we have 2, 1, 0. Okay. If P sub 1, since P sub 1 has already acquired its resources, all of its resources. Actually, it's already the max since you've already granted the request for the need. So, after its execution, what it's going to do? If you can remember, if the process has finished its execution, it should return all the allocated resources and then terminate. So, as we can remember, so need is equal to max minus allocation. But since you've already acquired the need, so we can derive that max is equal to need plus allocation. So since as it is said, once the process has already finished its execution, it should return all the resources that it has used. You have to return all the resources. So the what are you going to return is the maximum value for p sub 1. So what are we going to do is we're going to add the max value. So the max value is 3, 2, 2. So we have 0 plus 2, 2, 1 plus 2, 3, and then 2 plus 3 is we have 5. Then we already have 5, 3, 2. So since we've already finished p sub 1's execution, so it's already finished. Okay, which of them is next? So let's try the second candidate prior. We have p sub 3. So p sub 3, again, if you're going to grant its request, you have to subtract the need values of p sub 3. So minus 0, 1, 1, 0, 1, 1. So we have 2 minus 1 is 1. And then 3 minus 1 is 2. And then 5 minus 0 is 5. Okay? 5, 2, 1. And then after p sub 3 has finished its execution, so you have to return all its resources. So you have to return 2, 2, 2. So again, to return is you have to add. So plus 2, 2, 2. Okay? After adding 1 plus 2 is 3. 2 plus 2 is 4. 5 plus 2 is 7. So we have 7, 4, 3. So we've already finished the execution of p sub 3. Okay, next. Okay, 7, 4, 3 is the available resource for A, B, and C. So which of them fits? Okay, actually, it really fits p sub 0 already. And p sub 2 also. And then we also have p sub 4. It's just a matter of your choice. So what if I select p sub 4? Okay. So p sub 4. Okay, right here p sub 4. Again, you have to subtract the need from the available. So minus 4, 3, 1. So 3 minus 1 is 2. 4 minus 3 is 1. And then 7 minus 4 is 3. So the available is 3, 1, 2. And after p sub 4 has finished its execution, you have to return the maximum of p sub 4, which is 4, 3, 3. Okay, so add. You have to add 4, 3, 3. Okay. Okay, we're going to add. So 2 plus 3 is 5. 1 plus 3 is 4. And then 3 plus 4 is 7. So we're already finished with p sub 4. Okay, next. What's the next? So let's just choose from p sub 2 and p sub 0. So I'm going to choose p sub 2. So let's continue here. So let's just rewrite. So we have 7, 4, 5. And then we have p sub 2. Subtract the need. So 6, 0, 0. So we have 5, 4, 7 minus 6 is 1. Okay. Then after p sub 2 has finished execution, we have to return. Okay, p sub 2, we have to return the maximum, which is 9, 0, 2. Okay, so we have going to add 9, 0, 2. So we have 5 plus 2 is 7. 4 plus 0 is 4. And then 1 plus 9 is equal to 10. So already finished with p sub 2. And then next is we have our last but not the least is we have p sub 0. So again, subtract the need, which is 7, 4, 3. 7, 4, 3. Okay. So, 7 minus 3 is 4. 4 minus 4 is 0. 10 minus 7 is 3. And then, okay, since P sub 0 has finished its execution, we have to return the maximum values of the resource 753. So, we're going to add plus 753. Okay. Okay, 753. So, we have 7, 5, and then 10. Okay. How are we going to know if what we have done is correct? We have 10 resources for A, B is 5, and then C is 7. Actually, we can check it. We can verify if what we've done is correct because, as you can remember with the example, it is stated in here that the maximum number of resources for A is 10, B is 5, and then C is 7. So, as you can see, it's correct. So, 10, 5, and 7. So, that's the way that you can verify if you've done correctly the subtraction of the needed values and then returning the resources that is allocated by adding it to the available. So what does it mean, for example, if you don't get the correct number of resources in the end? So it's either you have made a mistake while adding or subtracting the resource value. So you have to be very careful. So this is the only way that you can check if you have correctly done the algorithm for Banker's algorithm. So, how are we going to do with the answer? So, we can say since it has completed 1, 2, 3, 4, 5, all of the 5 processes in execution and it's still in the safe state, so we can state it in here in a complete sentence. So, the system is in a safe state since the sequence okay, you have to state the sequence. That's why I told you to write the processes. So P sub 1, P sub 3, and then P sub 4, and then P sub 2, and then P sub 0 satisfies safety criteria. Okay, if the question is the system system safe, you just have to provide at least one sequence in which all the processes will be executed and all the resources will be returned. So that's the at least one sequence. So the question, I've already asked this prior. So is there a possibility that there is another sequence that can satisfy safety criteria? Actually, there is. So as you can remember, we have a candidate for P sub 1 and P sub 3. What if instead of P sub 1, you want P sub 3? What will happen? Okay, actually this sequence is already the answer in the slides, but I'll give you another example in which that you can we can demonstrate that even if you choose P sub 3, as long as it is it can be accommodated. Let's see if we can still produce another sequence that satisfies the safety criteria. Okay, so we have another example. So please allow me to rewrite again the need. So need for P sub 0, P sub 1, P sub 2, P sub 3, and P sub 4. So we have 7, 4, 3, and then 1, 2, 2, and then 6, 0, 0, and then 0, 1, 1, and then 4, 3, 1. Okay. So, let's rewrite again the available. So, available is A, for A, B, and C. Again, is we have 3, 3, 2. Okay. In our first example, we have this, as you can remember. We have chosen P sub 1. What if we want 2 is P sub 3? So, again, write P sub 3 here, and then subtract its need values. So, 0, 1, 1. So, we have 2 minus 1 is equal to 1. 3 minus 1 is equal to 2. And then 3 minus 0 is equal to 3. And then, again, we're going to return the resources allocated from P sub 3, which is P sub 3, 2, 2, 2. So, plus 2, 2, 2. So, we have 3. Then, 2 plus 2 is 4. And then, 3 plus 2 is 5. So, we already have 5, 4, 3. So, we've already done with P sub 3. Okay, so since 5, 4, 3, so P sub 0, it cannot be granted right away, of course, because of the 7 from resource A, and resource A is only 5. So P sub 1 can be accommodated. P sub 2 cannot be accommodated yet because the available, of course, of A is 5, while it needs 6 instances. And then 4, 3, 1. So, our candidate here is P sub 1 is P sub 4. So, our curiosity, let's try P sub 2 for this example. So, P sub 4. So, let's write P sub 4 and then subtract its need value. So, we have 4, 3, 1. So, 3 minus 1 is equal to 2, 4 minus 3 is equal to 1, and then 5 minus 4 is equal to 1. And then we're going, after P sub 4 has already finished execution, we have to return all its allocated resources. P sub 4's maximum resources is 4, 3, 3. Okay, so let's add plus 4, 3, 3. Okay, so 2 plus 3 is equals to 5. 1 plus 3 is equals to 4, and then 1 plus 4 is equals to 5. So, our available now is 5, 4, 5. So, we're already finished with P sub 4. So, next is 5, 4, 5. So, P sub 0 and P sub 2 cannot be granted. The only process that can be granted is we have P sub 1. So, again, P sub 1, then write its need and subtract it from the available. So, we have 1, 2, 2. Okay, so 5 minus 2 is equal to 3. 4 minus 2 is equal to 2. And then 5 minus 1 is equal to 4. And then, after P sub 1 has finished its execution, let's return its resources. The maximum is we have 3, 2, 2. So, plus 3, 2, 2. Okay. 3, 2, 2. We have 3 plus 2 is 5. 2 plus 2 is 4. 4 plus 3 is 7. We have 7, 4, 5. Okay. Okay, next is we have P sub 0 can be accommodated in P sub 2. So, though P sub 2 is lower than P sub 0, but not in A, but not in B. So, for a change, let's try P sub 0 first. Okay, we have number 4. So, let's rewrite it again. So, 7, 4, 5. And then P sub 0. Again, subtract its need. We have 7, 4, 3. Okay, 7, 4, 3. 5 minus 3 is 2. 4 minus 4 is 0. And then 7 minus 7 is 0. And then again, we need to return the resources of P sub 0 if it's finished with execution. So, 753, its maximum resources. So, plus 753. So, we have 5. 2 plus 3 is 5. 0 plus 5 is 5. And then 0 plus 7 is 7. So, we have 755. Okay, then last but not the least is we have resource P sub 2. Subtract the need value. So, we have 6, 0, 0. So, we have 5, 5, 7 minus 6 is 1. And then, after P sub 2 has finished its execution, so P sub 2, maximum value, resource values is 902. So, we have to return it. So, plus 902. Okay, so 5 plus 2 is 7. 5 plus 0 is 5. And then 1 plus 9 is 10. Again, let's check if the maximum for A is 10, B is 5, C is 7. So, 10, 5, 7. So, let's check. 10, 5, 7. So, again, it is correct. So, again, let's conclude that the system is in a safe state. Okay, safe state since the sequence, okay, we have P sub 3, P sub 4, P sub 1, P sub 0, and P sub 2. So, P sub 3, P sub 4, P sub 1, P sub 0, and then P sub 2. Okay. Satisfies safety criteria. Okay. So, the system is in a safe state since the sequence P sub 3, P sub 4, P sub 1, P sub 0, and P sub 2 satisfies safety criteria. So, I only gave this another example to show you that for a set of processes, you can identify many number of sequences applicable. So, the question is, do we need to identify all the sequences? Actually, you don't need to identify as long as you have identified one sequence that satisfies the safety criteria. You can already conclude that the processes that is executing is in a safe state. But, for example, in your first try, the processes did not finish. You have to exhaust all of the sequence available. And then, if you already exhausted all of these available sequences, and then it does not really executes all the processes. So, it means these sets of processes are in a deadlock or in an unsafe state. Okay? Again, I just want to reiterate, you only need one sequence to prove that the system is in a safe state. I just gave this example, another sequence, so to show you that it is possible that a set of processes and set of its resources allocated need may have one or more sequence as an answer. Okay? So, next is, we're already finished with this example. So, what if, for example, P sub 1 requests additional resources? So, what if P sub 1 requests additional resources 1, 0, 2? It means it wants additional 1 instance for A. It does not need anything from resource B. And then it wants another 2 instances from resource C. So, what are we going to do now? So, again, let's return with our example. So, we have this one. So, since P sub 1 requests, what are we going to do? Check first the available. So, if we're going to check 102, can this be allocated or granted? Actually, yes, because the available is greater than the request. So, it can still, because it only needs one resource from A. So, we have 1 and then it does not need anything. So, 0. And then, it needs 2 for C. So, what we're going to do here is we're going to subtract. So, subtract the request 1, 0, 2. So, we have 2 minus 2 is 0, 3 minus 0 is 3, and then 3 minus 1 is 2. So, this is our new available. Okay. And another one, if you've removed, if you granted the request of P sub 1, which is 102, and then you subtracted it from available, you have to make sure that in P sub 1, you should add 102. So, plus 102. So, what will be its new value? So, its new value will be what? So, we have 2 plus 1 is we have 3. And then 0 plus 0 is 0. And then 2 plus 0 is 2. So, our new value for P sub 1 is 3. Okay. Since we have a change in the value of P sub 1, so, again, we need to derive the need matrix. So, let's derive the need matrix. So, again, need matrix. Need is equal to maximum minus allocation. So, A, B, and C. So, P sub 0, P sub 1, P sub 2, P sub 3, and P sub 4. Okay. So, actually, the only change here is P sub 1. So, for P sub 0, it just remains the same. As you can remember, we have 7, 4, 3. And then, for P sub 2 is 6, 0, 0. And then, P sub 3 is 0, 1, 1. And then, P sub 4 is 4, 3, 1. We just need to get the new value for P sub 1. So, 3 minus 3 is what? Okay, 3 minus 3 is equal to 0. And then 2 minus 0 is we have 2. And then 2 minus 2 is equals to 0. So, the new value for P sub 1 in the need is 0, 2, 0. And then, we're going to do the algorithm of course, for safety algorithm of Banker's algorithm. So, again, our new available resource now is 2, 3, 0. Just like what we did, let's see if it's still, if P sub 1 request 1, 0, will the processes will finish its execution and satisfies the safety requirements. So, our available is what? Okay, as you can remember, is 2, 3, 0. Okay, 2, 3, 0. So, among the processes here which can be granted immediately, of course, P sub 0, it cannot be. It's too high. 7, then 4, and then 3. 2, 3, 0. So, P sub 1, can it be granted? Actually, yes. It does not need any resource from A. It needs 2. The available is 3. And then, it does not need any resource from C. So, this is our possible candidate. P sub 2, it's not possible because, again, resource A is too big. We have 6. Though B is 0. But, of course, we have to make sure that all of the resources must be acquired all at the same time. Okay, P sub 3. Is it possible? Actually, no, it's because of resource C. Because resource, it needs 1, but the available for C is already 0. And then, of course, for P sub 4 is 431. This is also not possible because resource A has 2 high needed resource. And then also for C, the only one that can be accommodated is resource B. But then again, it should be accommodated. All of the resources must be accommodated. So, our only possible candidate here for execution is P sub 1. So, let's write P sub 1. So, subtract its need values 0 to 0. So, we have 0, 3 minus 2 is 1. 2 minus 0 is 2. So, we have 2, 1, 0. And then, let's return to P sub 1 after it's finished its execution. Return its maximum resource value. So, we have 3, 2, 2. So, plus 3, 2, 2. So, we have 2. 1 plus 2 is 3. 2 plus 3 is 5. We have 5, 3, 2. Okay. So, our available is already 5, 3, 2. So, P sub 0, it cannot be accommodated yet. Also, P sub 2. Okay. Possible candidate now is we have P sub 3 and P sub 4. Curiosity again. Let's just choose. Actually, it's safer to choose P sub 3. But let's see if we can do P sub 4. So, P sub 4, so subtract its need. So, we have 4, 3, 1. Okay, so we have 2 minus 1 is 1, 3 minus 3 is 0, 5 minus 4 is 1. And then, P sub 4, finish its its execution. So, let's return the maximum resource value. So, minus 4, 3, 3. So, we have, okay, so 1 plus 3 is 4, 0 plus 3 is 3, 1 plus 4 is we have 5. So, we've already finished with process P sub 4. Okay. Next is we have, okay, 5, 3, 4. So, again, P sub 0 and P sub 2 cannot be accommodated yet. So, next is we have P sub 3. So, subtract its need resources. So, we have 0, 1, 1. So, we have 4 minus 1 is 3. 3 minus 1 is 2. Then, 5 minus 0 is 5. Okay, then again, we have to return the resource values of P sub 3. We're already finished its execution. So, P sub 3 is 2, 2, 2. Maximum resource value plus 2, 2, 2. So, we have 3 plus 2 is 5. 2 plus 2 is 4. And then 5 plus 2 is 7. So, we have 7, 4, 5. So, again, this is our third P sub 3. And then, the next is, which one? Okay. Do you want to execute? So, of course, what if I want, I've already made an example for P sub 0. So, let's choose P sub 2. Okay. So, for number 4, let's rewrite 7, 4, 5. So, we have 7, 4, 5. Then, P sub 2. Subtract its need value, resource value. So, we have 6, 0, 0. So, we have 5 minus 0, 5. 4 minus 0 is 4. 7 minus 6 is 1. And then, okay, we're already finished with P sub 2. Finish its execution. What's its maximum resource values, we have 902. So add 902, 902. So we have 5 plus 2 is 7, 4 plus 0 is 4, 1 plus 9 is 10. So we have 10, 4, 7. And of course, last but not the least is our last process. So P sub 0, subtract the need. So we have 7, 4, 3. So 7 minus 3 is equal to 4. 4 minus 4 is equal to 0. 10 minus 7 is equal to 3. So 304. And after finishing its execution, so let's return its maximum resource value, which is 753. So plus 753. So 4 plus 3 is 7. 0 plus 5 is 5. 3 plus 7 is 10. Again, let's check. So for resource A, 10, B is 5, and then C is equal to 7. Total number of resources, 10, 5, 7. So we have again 10, 5, 7. So this is correct. So we can conclude that, let's have a conclusion, the system is still in a safe state since the sequence, okay, the sequence again, let's enumerate the sequence. We have P sub 1, P sub 4, P sub 3, and then P sub 2, P sub 0 satisfies safety criteria even. Okay, let's just add even P sub 1 requests additional resource, which is our additional resource is 102. So again, this example, the system is still in a safe state since the sequence P sub 1, P sub 4, P sub 3, P sub 2, and P sub 0 satisfy safety criteria even though P sub 1 requests additional resource, which is 102. Okay, actually in the presentation, so actually the sequence in the presentation is P sub 1, P sub 3, P sub 4, P sub 0, and P sub 2. Actually, it depends again. You just need to identify one sequence that will complete the execution of the processes that's still in the safe state. It does not matter as long as you identified one sequence. Okay, there is also another question. So, can P sub 4, okay, request of P sub 4 is 330 be granted after you've already granted P sub 1's request, which is 102. So, another to answer the question is P sub 4 request what? We have 330. Okay, can the request be granted? So let's return with our example. So what we need, P sub 4 needs 3 resources for A, for B is also 3, and then it does not need any from resource C. As you can see, our available is 230. Okay, can the request be granted for this one? Actually, as you can see, for resource A, it's not enough. Okay, because the allocated, the requested resources here is greater than 1. So, our answer here is we can state that no, because there is not enough resource available. So you can answer that. So no, because there is not enough resource available. You can specifically resource A. Okay, that's already enough. Because P sub 4 requests for resource A and 3 instances, but the only available now is 2 instances of resource A. Okay, so another request. What if can P sub 0 request for P sub 0 request 0 to 0. So it means it requests additional 2 resources from B. Okay. Can this be granted? So let's check again our available values, resource values. So we have 2, 3, 0. So P sub 0 asks for additional 2 instances. Can it be granted? Actually, it can be granted. So what are we going to do again if can be granted? So you have to subtract the requested value, resource values from the available. So let's do that. So 0 minus 0 to 0. So we have 0, 3 minus 2 is 1, and then 2 minus 0 is 2, 1, 0. So this is our new value for available. And then, of course, we have to add a 0. We have to add here, rather. We have to add. It's not here. 0 to 0. So what's the value now? The new value of P sub 0 is what? We have 0, 2 plus 1 is 3, and then 0. So that is our new value for P sub 0. So, what are we going to do again? Can this be, is it a safe state if we're going to grant and then continue to continue with the process for the processes execution? So let's check again. So we have to derive the need matrix. So again, need, again, A, B, and C, P sub 0, P sub 1, P sub 2, P sub 3, and P sub 4. Okay, as you can remember, we have, okay, the only value that has changed here is what? The only value is P sub 0. So, let's retain P sub 1, P sub 2, P sub 3, and P sub 4. So, P sub 1 is what? 0, 2, 0. Then, P sub 2 is 6, 0, 0. Let's just copy with the previous values. And then, P sub 3 is 0, 1, 1. And then, P sub 4 is 4, 3, 1. So, what is the value of need? So, we have, okay, P sub 0. 7 minus 0 is 7. Then 5 minus 3 is equal to 2. And then 3 minus 0 is equal to 3. Okay. And our available now, as we can remember, is we have 2, 1, 0 are available. So, A, B, C, 2, 1, 0. So, can we accommodate P sub 0? No, definitely. It needs 7 instances of A, for B is 2, and then for C is 3. Then we have P sub 1. Okay, it can accommodate A, but it cannot accommodate A and C, but it cannot accommodate resource B. So this is not also possible. So P sub 2, of course not, because of resource A is too high. And then for P sub 3, actually resource A and B can be accommodated for P sub 3, but for C, we already have value of 0, so it cannot be granted. And then of course for P sub 4, for actually for all of them, A, B, and C cannot be granted. So too large, then it's also large, big, and of course it needs 1, and then available is 0. So what is this? So what will happen? So you granted the request of P sub 0, but while identifying which of the process will be executed first, the available resource is not enough. So though the resources for this example, the answer, so though the resources requested by P sub 0 can be granted, as we already seen, but the system is in unsafe state because there is no sequence of the processes that satisfies the safety criteria. So we can write that. So though the resources requested by P sub 0 can be granted, but the system is in unsafe state because there is no sequence of processes that satisfies the safety criteria. So again, so the answer, the reason is, so though the resources requested by P sub 0 can be granted, but the system is in unsafe state because there is no sequence of processes that satisfies the safety criteria. So this is already the last question. If can request 020 by P sub 0 be granted? So of course, this is the banker's algorithm. We're using banker's algorithm to determine if the system is in safe state. So if you do have any questions, so please feel free to comment below, and please don't forget to subscribe to my YouTube channel. And then thank you very much. So I hope that you've learned something and you understand the mechanism of the banker's algorithm. So thank you very much and good day.